everyone, and welcome back to another professional prep video. In this video, I'm going to be discussing continuity. So, continuity relates greatly back to limits, so make sure you have a firm foundation on those. But if so, let's get started. So, say that we have this function f of x, and it's a piecewise function. You can see it defined on the screen. And we want to know if f is continuous or not. So, we might have some definitions of continuity that we learned previously, but let's look at, we have a calculus definition of continuity, and that's what we want to use from here on out. So let's look at that. So first of all, in order for a function to be continuous at a certain point, the function needs to be defined at the point. The limit from the left needs to equal the limit from the right at that point, and the limit as x approaches that point needs to equal the value of the function at that point. So let me do an example to help us out with understanding that definition. So say we want to determine whether f is continuous. So here you can see x plus 7 and x squared minus 13. They're both continuous functions themselves. So that means the only place where we wouldn't have continuity is at the break, or 5. So we need to test continuity at 5 in order to determine if f is continuous or not. So let's look at our first case. Is f defined at x equals 5? And sure enough it is. This x plus 7 is, as x is greater than or equal to 5. So we have the definition. So that's our first check mark for continuity. Now we need to compare the two one-sided limits, or from the left and from the right, and see if they're equal. So this is where our limit knowledge is going to come into play in order to determine our continuity. So let's evaluate the limit as x approaches 5 from the left of f of x. So from the left, we use that x plus 7 function because that holds true for all values of x. We use the x squared minus 13 function because that holds true for all values of x less than 5. And so sure enough, let's solve this. By the way, I know usually you see the less than on top of the greater than or equals to. It's the same thing. I was just writing this. I must have written it like that, but it's the same thing. So now this is going to be equal to 5 squared minus 13, which I believe is going to be 12. So now we need to check the other one-sided limit to see if that's equal. So now we've got the limit as x approaches 5, this time from the right, of f of x. So I just want to point out, since the positive side compared relative to 5 is the equal to, this is also going to be equal to f of 5. In order for continuity to exist, the point needs to be defined on the function, which we already checked off. And these three values that I'm underlining right now need to be equal. If those three values are equal, then we can say that the function is continuous at that point. These three underlined values need to be equal in order for continuity to exist. And so let's solve this out. So from the right, we have x plus 7. So that's going to be substituting in 5 for x. This is just direct substitution. We're going to get 12. And sure enough, all three of our values are equal. So that's another check mark. So our answer is yes. The function is continuous. And you might be wondering, but we only check that it's continuous at x equals 5. And you'd be absolutely right. But it's continuous everywhere because it's composed of these two piecewise functions that are both continuous for all domains. So for that reason, we're going to say that it's continuous everywhere. So this function f is continuous everywhere. And so for a quick example, let's say that we change the 7 to a 6 here. Then all of a sudden this value becomes 11. And now this value here is not going to be the same as that and that. And for that reason, it would be no. This is not continuous. F is not continuous if that were a 6. And so that's why we're going to say that it is continuous, though, with our original function, which was x plus 7. So that's all I have for this video. If you have any questions, please feel free to email us or leave a comment. If not, have a great day, and I will see you for our next video. Thank you, everyone, and be sure to subscribe.